This is the Puente Hills landfill outside Los Angeles, California. The first truckload of trash was dumped here in 1957, and the trucks just kept coming. For more than 5 decades, if you threw something away in LA County, there's a good chance it's buried somewhere in this mountain of waste. At its peak, Puente Hills was accepting around 4 million tons of trash every year, making it one of the largest landfills in the country. It closed in 2013, creating a time capsule of everyday life and consumption patterns over the span of 56 years. But Puente Hills is also a time capsule of landfill engineering itself. In 1976, right in the middle of its lifespan, sweeping federal regulations changed how we deal with solid waste forever. You probably don't think too much about where your trash goes, and that's kind of the whole point of the solid waste industry, to make sure.
That is true. I often don't think about the waste and where it goes. Definitely, this is a different type of engineering than I'm familiar with, so I'm excited to see where this gets taken.
You have the ability to throw something away without it having a serious negative consequence on the environment or public health. There's a larger conversation to be had about the amount of waste we generate and how much of it can be recycled or reused, but there's always going to be stuff that just doesn't hold enough value to be kept. Trash is an inescapable element of the human condition, and I think you're going to be surprised at how complicated that really is. When Puente Hills opened in the 50s, a landfill was pretty much just a hole in the ground where trash was dumped. By the time it closed, landfills were highly engineered holes where trash gets dumped. And I have a scale model of a landfill in the garage to show you how it all works. I'm Grady, and this is Practical Engineering. There are lots of kinds of waste in this crazy world, but one of the biggest sources is just you and me throwing stuff in the trash. The technical term is municipal solid waste, since its collection is usually coordinated at the city level. There are a lot of ways to manage it once it's collected, but the most common by far is disposal in a landfill. And one of the biggest parts of landfill engineering is just deciding where to put one in the first place. The main goal of a landfill is to maximize the volume of waste that can be stored there, while minimizing the cost and the environmental impacts too, which turns choosing a suitable site into a giant geometry problem. Digging a hole sounds like an obvious choice, but consider this. Digging a hole is expensive, and not digging a hole is free. There are costs of excavating tons and tons of soil just.
Yeah, that makes sense. Obviously, costs and profitability are going to come into play for basically aspects around society. And so clearly that's going to impact this area as well. Definitely making me think more about how this actually happens and my own contribution to this. Generally speaking, I do try to minimize how much waste I have. I try to only buy the things that I need, generally try to reduce food waste and other types of waste and try to recycle as much as I can. But certainly, I think it's an inescapable part of our lives, just given how everything that we interact with and the things that we need and to live and eventually do need to end up somewhere at the end of the day. And not everything that we're going to own or interact with is going to be compostable or recyclable. So this is definitely an interesting problem that probably many of us don't think about all that much.
To get it out of the way so it can be replaced with trash, and costs of hauling away all that soil, since your goal is to maximize the volume on the site. Plus, you have to avoid the water table, any unsuitable geology, and the challenges of building and working deep below the surface of the earth. That's why landfills mostly build up into what sanitation professionals call the airspace. Looking upward, it may seem the sky is the limit, but anyone who's built a tower of anything, let alone trash, knows better. The waste pile gets less stable as its height increases, requiring shallower slopes. And the pressures at the bottom go up too, which can lead to settlement and damage of facilities. Plus, there are visual impacts. The bigger the garbage heap, the bigger the eyesore, and people are only willing to look at a landfill so tall. They can't be too close to airports because they attract birds that can interfere with planes. And they can't be too close to homes, parks, playgrounds, and other places people congregate for obvious reasons. Of course, there's floodplains and wildlife habitat to avoid as well, and you don't just need a place to put the trash, you also need a scale house to weigh the trucks coming in and out, a shop and storage for the equipment, and sometimes a place for ordinary citizens to drop stuff off. Finally, you need a spot that can handle the huge increase in truck traffic coming and going practically non-stop. Pretty much, if you can get a college degree in it, it's going to come into play when siting a landfill. Geology, geography, politics, archaeology, public relations, biology, every kind of engineering, and a lot more. But once you have your landfill, you can't just start dumping trash.
Yeah, that's a great point. There's actually probably so many aspects I don't consider myself since um, I'm from software engineering, and so most of what I consider is mostly theoretical. There isn't a lot of physical aspects to it. But that's a very good point that there's so much engineering that is required for our day-to-day lives that we probably take for granted that exist and probably require so much thought and energy from so many different disciplines in order to make it successful. So I'm definitely enjoying this video so far.
Let me show you why with a demonstration, and I have some help from my shop assistants. I have my hole dug, and we'll start adding some trash. So far, no major
Future engineers in the making here.
problems, but eventually it's gonna rain. And you can immediately see the issue. Granted, this is more of a flood than a drizzle, but it gets the point across. All that water is gonna filter through the garbage to the bottom of the hole and eventually into the underlying soil. It might go without saying, but I'm gonna say it anyway, we really don't want garbage juice percolating into our soils. Mainly because it can contaminate sources of groundwater, but also because it can migrate well beyond the limits of the landfill, causing all sorts of environmental troubles. So modern landfills use a bottom liner to keep waste separate from the underlying soils. Often this consists of a thick sheet of plastic, carefully tested and welded together into an impermeable membrane. Even the area between the plastic welds is tested using air pressure to make sure there are no leaks. Another option is thick clay soil compacted to create a watertight layer. In many cases, the two options are combined, so you end up with this intricate structure of different impermeable layers stacked together. Maybe you still see a problem with the solution on its own. Now when it rains, the landfill just fills up with water. This causes issues with stability and settlement. It causes garbage to decompose more quickly, leading to odor and temperature problems. Plus, you just can't work on top. There's no way for trucks to unload trash on top of a garbage swamp. So we need a way to get the garbage juice out without letting it flow into the soil below. By the way, garbage juice is not a technical term, it's actually called leachate, so I'll use that from here on out. And all modern landfills have sophisticated leachate collection systems to keep the waste as dry as possible and avoid the issues I mentioned. Usually this consists of a system of perforated pipes covered in a layer of sand, draining to sumps and eventually leading out of the waste. I built a little leachate collection system in my model landfill using a small tube so you can see this in action. Now my clay bathtub has a drain.
It's interesting. So basically they create effectively a bowl to keep everything in, and then they added drainage segments so that way they can particularly handle the water that comes from that waste area. Um, Interesting process that they have here. I'm also curious to see where that goes and how they treat that waste product. Presumably that has to go to some type of treatment center. Otherwise, that would again kind of have the same problem that I mentioned earlier of just kind of leaking out into the surrounding soil. So curious how that actually gets processed.
When the rain comes, the water that makes its way into the waste is able to flow out of the landfill, keeping it from becoming a swampy mess. This is a little simplified compared to a real landfill. I've made a video all about French drains, which is much closer to what a leachate collection system consists of if you want to learn more after this. Obviously, in my example, the leachate collection system has to penetrate the bottom liner, which can be a potential source of leaks. So these penetrations are sealed really carefully in the real world, Or the collection system just uses pumps and risers that run up the slope of the landfill to the top, so no penetration system is necessary. Of course, now you have a stream of leachate you have to deal with. Actually, leachate management is one of the biggest costs of running a facility like this. Some landfills send it off.
Not sure if folks should be drinking things that come out of sand uh, trap type of thing going on here, but I guess glad this individual thinks so highly of his hygiene and this experiment that he set up that he was willing to do so.
To a treatment plant that can clean it up. Some have ways to treat it on site with settling ponds, evaporation, biological treatment, and even plants that can consume and convert landfill leachate into waste that's easier to dispose of, maybe even back into the landfill itself. Finally, the bottom of our landfill has all the necessary pieces, but the work doesn't stop there. Remember that volume is everything in a landfill. For as much effort that goes into finding a location and building the infrastructure, it's essential that we get the most trash in here as possible. You probably know this, but municipal garbage just isn't that dense. Maybe you've had to smash a few more bags in the can because you missed the collection one week. If so, you know there's usually a lot of room for densification. The trucks that collect garbage usually have a way to compact it to make more room in the box before needing to be emptied. But once the trash is at the landfill, there's still an opportunity for compaction. Landfills often use massive roller compactors with enormous teeth and giant blades to grade out and compress waste and get as much as possible into the site. It saves money and it's good stewardship of the space. But density isn't the only challenge with day-to-day operations. Despite what you've heard, landfills are kind of gross. I mean, that's their whole point, to accept the stuff we don't want to put anywhere else. But putting it all in one place creates a lot of problems. Pests, odors, windblown waste, fires, birds, and more. So to mitigate some of that, most places require that the garbage be covered up at the end of every day. This daily cover can take a lot of forms. The basic approach is...
That's interesting. I wonder what the purpose of this coverage is. I wonder if it's to help kind of level things out as they're starting to demonstrate here, or if this is just like a visual aspect to kind of minimize people's concerns around the landfill itself. Curious to understand if this is more of a aesthetic purpose or if there's actually an engineering principle behind this.
Just to put a layer of soil over the top of the working face at the end of the day. When I do this in the model, you get a sense of the problem. All that clean daily cover is taking up precious space in the landfill. One option is to trim it back off each morning before the trucks start arriving, but that's a Sisyphean task of just moving tons and tons of soil around each day. Other alternatives for daily cover are tarps, or just holding back certain types of waste that are more inert, like foundry sand, foam, paper, and shredded tires. They're going in anyway, so you might as well use them on top to cover the more disagreeable stuff overnight. Those alternatives can also help avoid leachate getting perched within the waste, encouraging it to continue downward to the collection system. Ideally, a landfill will last for decades, slowly filling up by packing in as much waste as possible. Throughout the course of operating a landfill, there's constant testing of groundwater, surface water, leachate, air quality, and more to make sure they're not exceeding limits. Landfills are usually built in smaller cells, so you don't have to manage this huge area of waste all at once. A cell fills up, you put soil over the top, called interim cover, and start a new one within the landfill. But eventually, you reach the top of the airspace, and the landfill reaches the end of its useful life. And closing a landfill is not an easy job. Of course, you have to cover all that waste up, creating a mountainous sealed tomb of garbage.
That's an interesting aspect. So there seems to be some effective inefficiency in these landfills in so much as covering them. I didn't really hear him describe a logistical necessity for that, other than I'm assuming this is some type of mitigation strategy for concern from communities, which is interesting that we actually make landfills less effective, and then therefore probably creating more landfills for that reason. It's also interesting that they effectively kind of seal off this bowl, as described before. Um, Curious to understand where they take it next. I would have hoped that they are doing some type of treatment to this area in order to help responsibly um, degrade this waste over time, so that way there aren't drastic negative effects. It seems as though they're kind of just encapsulating it entirely to try to avoid negative implications down the road, as opposed to necessarily maybe proactive treatment of it. But curious to see what he describes next.
Cover has to keep the water out to reduce the volume of leachate you're having to collect and treat over time, but it also has to keep the garbage in. And not just the garbage itself, but everything else that comes with it, like smells and leachate and pests. And it has to do it basically forever. So just like the bottom liner, the final cover over a landfill is usually a system of multiple layers, including compacted soil, membranes, and fabrics. And then you have to get the grass to grow to protect the soil from erosion and damage over time. I don't have time to wait for grass to grow in my demo, so I'm cheating a little bit. But the fun isn't quite over yet. The waste may be sealed up, but that doesn't mean it's inert. In fact, there's a lot of chemistry and biology happening inside a landfill. And a lot of those reactions generate gases like methane and hydrogen sulfide that can create pressure, heat, smells, greenhouse effects in the atmosphere, and the potential for explosions. So one of the steps in landfill closure is to install wells that can collect the gases from the waste. Usually these consist of vertical pipes connected to a blower that constantly draws air to a collection point. There's a lot that goes into these systems too. You can't pull too hard or you might draw oxygen into the landfill, changing the reactions and microbiological processes and creating a potential for a fire within the waste. Plus, the gas includes a lot of humidity, so managing condensation creates another liquid stream that has to be collected and treated. Once it's collected, the landfill gas can be flared, combusting it into less environmentally harmful constituents.
Interesting. So he is starting to describe kind of what they do in order to help treat these landfills after they're kind of sealed up. But it's interesting that so far he's only really described the gas of it and basically trying to minimize the harmfulness of that gas through basically setting it on fire in order to presumably break it down into other components or change the type of gas that is actually being released. Again, he also kind of mentioned presumably that these would be sealed forever. So again, it seems kind of like a masking of this problem more so than anything else, but maybe he's going to continue into other treatment that they do for these landfills.
Another option is to put it to beneficial use to create heat or even electricity. The Puente Hills landfill I showed earlier has a gas-to-energy facility that's been running since 1987. And even though the landfill is now closed, it currently provides enough electricity to power around 70,000 homes. Once a landfill...
That's actually pretty awesome. Basically, actually leveraging some of this decomposition process and then actually leveraging that for generating electricity seems to be like a very useful option from here. I guess almost like a upcycling, for lack of a better term, on this system in order to help kind of lead to better outcomes. So definitely a fan of that. Interested to see what other options exist.
Closed, there's not a lot you can do with it after that. It's a big sealed up mountain of trash after all. Owners are generally required to look after a closed landfill for at least 30 years afterwards, inspecting for leaks, monitoring the air and water, and repairing any damage. Those costs have to be built into the rates they charge since there's not a lot of benefit or revenue after closure. But with all that open space and carefully maintained landscaping, one option that many landfill owners are trying out is parks. And I love this idea.
I think it just said parks. So that's an interesting aspect. So I guess they're trying to convert these landfills into recreational space for communities. However, the fact that he also just described that they have to put in effort and time and money in order to help potentially mitigate issues that just happened with that landfill, I'm not sure if I'm as excited as this individual appears to be about this prospect. I'm not sure if I'd want to be hanging around in a park or my family or loved ones in a park that could potentially be part of a landfill that presumably could at any point um, have some degradation and then lead to some unintended consequences there. Um, I'm not sure if I'm thrilled about that idea, but maybe he's going to describe how they mitigate this risk as part of this process.
They say, we're willing to put our money where our mouth is and invite the public to spend time here, to enjoy this place that used to be, one of the least enjoyable places you can imagine. Puente Hills in California has big plans, including trails on the slopes, biking, slides, gardens, and more. It looks like it'll be a really nice place to visit when it's done, and it also puts the whole concept of landfills in perspective. Of course, we have a lot of room for improvement in how we think about and manage solid waste in this world. Landfills seem like an environmental blight, but really, properly designed ones play a huge role in making sure waste products don't end up in our soil, or air, or water. It's not possible to landfill waste everywhere. Many places are too densely populated or just don't have enough space. But where they are, the environmental impacts are relatively small. Just consider the resources that go into them. I pay about $20 a month, probably a little on the low end of the national average, and that buys me 64 gallons, about a quarter of a cubic meter of space in a municipal landfill per week. Of course, I don't fill the can every week, and that trash gets compacted, but still. Do that for a decade, and your $20 a month is paid for the volume of a modest apartment. It's covered the cost of building the lining and collection systems, the environmental
Just going to take a moment there. That's actually kind of crazy to think about, of just how much space all of our waste takes up, that it can become a sizable segment of the world, really, and the environment that we live in. And he basically just described, like, over the course of a year or so. Obviously, many of us live hopefully long lives, and so that's actually a lot of space that we probably don't even consider or think about, of how much is actually kind of leaving our homes and kind of accumulating in other areas, potentially nearby or out in the world.
monitoring the daily operations, the closure, the gas collection, and the maintenance for at least 3 decades afterwards, and for your trash to stay there effectively forever. It's almost free real estate. Not that you'd want to live there. But my point is, landfills are a surprisingly low-impact way to manage solid waste in a lot of cases. I hope the future is a utopia where all the stuff we make maintains its beneficial value forever, but for now I'm thankful for the sanitary engineers and the other professions involved in safely and economically dealing with our trash so we don't have to. I could spend hours talking about the engineering that goes into landfills. There are just so many practical challenges that you really don't face anywhere else in engineering, and it's kind of a small club of people who work on them and know a lot about them. I love that kind of stuff, and I have to assume you probably do too, which is why I want to recommend another video series I think you'll find interesting: The Logistics of X. This is produced by my friend Sam from the Wendover Productions channel. It's a series that takes a peek behind the curtain of stuff that we kind of take for granted. This episode on coal mining is so good. It covers all the things I would naturally wonder about: the heavy equipment, surface and underground methods, processing, transportation, and the major shifts happening in the industry. The graphics they use remind me of the old History and Discovery Network shows I used to love, and if you want to check it out, it's available to watch on Nebula. You probably heard of Nebula. It's a streaming service built by and for independent creators. I don't know about you, but that's most of what I watch.
Well, he's getting quite a bit into promotion of some future content. I did actually really enjoy this segment so far. I think definitely an interesting aspect to kind of dig in a little bit into the engineering of kind of the world around us and aspects of our lives that we might not think about as much. I definitely recommend folks checking this individual out. We'll have this video and the individual's channel linked in the description.
These days, I just like the authenticity and thoughtfulness of videos that haven't been through a writer's room and 10 levels of studio executives. Someone said Nebula is like Netflix for people who love trains, and I like that comparison, not just because I also love trains. Nebula is totally ad-free with tons of excellent channels and lots of original series and specials like The Logistics of X. It's also a great gift, especially because a yearly membership is 40% off at the link in the description. My videos go live on Nebula before they come out on YouTube. If you're with me that independent creators are the future of great video, I hope you'll consider subscribing. That's go.nebula.tv/practicalengineering. Thank you for watching, and let me know what you think.
Well, also thank you for watching this. If you enjoyed what you saw, please hit like or subscribe, and I will see you around.